I've been asked, how do I heat my house in the winter? In this video, I'll show you. Well, as some of you probably guessed, this is not my home, not my boiler. This is a buddy of mine's. It's a 129,000 BTU per hour heating oil unit. And this unit works great for him. He has a modest home and this works. But this is actually on the small side of the boilers I used to see in my daily job. But even if you combine the load of my house and my garage, this thing would be so far overkill for that that there'd be no need for it. It's too much. So we're going to go through some of the ways that I get heat in my small, super insulated house. It's a pretty small load. So let's go through it. We just came out of a wicked cold stretch here. Average temperatures were, I don't know, below zero. We had negative degrees every single night. We were lucky if we got up to 5 degrees during the day. And this was the whole last week. So good timely question, how I heat my house in the winter. And behind me, you can see that we have two very large south-facing windows. Those are the very first source of heat that we have for the home. Now, this is not a passive solar house in that I haven't designed it strategically with thermal mass to swing us through cold stretches. Nothing like that. However, during a day that is sunny, we will get plenty of heat coming in through those south-facing windows to heat the house without any additional heat. But once that sun goes down, we do need to turn on some form of active heating. Our second form of heating for the house might not be initially thought of. This is called internal gains. Now, usually when you're designing a whole big house, internal gains are just neglected because they're just such a small percentage of the overall load that you'll have. But in our home, because we're super insulated, it's a fairly large chunk of it. So if you cook on the stovetop, oven, the refrigerator, the lights, the humans, we all give off heat. And that's all part of the internal gains. So that internal gains is our second form of heat. And in fact, if everything else failed, we could actually turn on just one of these burners and heat the whole house. Now, usually when people ask me what my heating system is, they want to know about this unit. Now, this is a mini split heat pump, or sometimes called a ductless heat pump, because there's no ducts on it. The refrigerant lines go straight through this wall and out to the compressor outside. Now, this unit is pretty nice. It's a good quality unit with a very high SEER rating for the air conditioning side of it. That's a 27 on this unit. And that's the primary reason why I bought it. But it's also was touted as being at least a COP of 3, or coefficient of performance, meaning it should be at least 3 times more efficient in the winter than my, say, baseboard electric, which I'll show you in a minute. However, I've been incredibly disappointed by this unit. It doesn't hold up to that at all. The best I can get is a COP of 2, and actually with the wicked cold stretch that we just came out of, where we were having negative 10 degree nights in a row, this unit was just in defrost mode the whole time. It would only be in, and I wound up turning this off and just going back to the electric resistance. It gets really loud when it goes into defrost mode. It cools off the room, so if you're in this room, you get the blast of cold air because it just switches to air conditioning mode when it does that. And during a snowstorm, it just is solid frost on the coils. So my experience with these units, high initial cost, extremely high service cost. Every 2 years now I've had to get a service done on it. So I've paid for 2 services because the refrigerant keeps leaking out of the unit. And that's not under warranty. So I don't recommend these. I know that they're incredibly popular, and that'll probably hurt some people's feelings, but I don't recommend them. Just one service call alone will wipe out any energy savings that you've had on these units. So personally, if next time this goes, I'm just going to rip it out. That's the hard fact of it. Now we're down in the crawl space, so I can show you this guy. This was an $80 electric resistance baseboard heater. Very simple, standard, off-the-shelf unit. It is 2500 watt at 240 volts. I have two thermostats wired in series. One thermostat down here in the crawl space is keeping the crawl space at 80 degrees. The second thermostat is upstairs in the living space, and that keeps it at whatever we set the temperature to, currently 70 degrees. Now, the reason why I set it up that way is I didn't want this guy just running non-stop and warming this crawl space up to 100 or something. So having it at about 80 degrees down here has worked really well. Now, if I needed to, I could bump that or whatever, I could change it, but that's what we have it set to. Now, I really like this system, even though it's supposedly the most inefficient system out there. The reason is, it was cheap. Like I said, 80 bucks. Haven't had any service calls on it. It hasn't given me any issues. And that's a lot compared to that mini split that I just showed you upstairs. Also, this guy's quiet. There's no fan involved. I mean, it's also, during the snowstorms, we can run this. I can't run the other unit because it frosts over. During the extreme colds like we just came out of, I can run this. I can't run that mini split because it keeps going into defrost mode. So I really like this. Having a I really like having the electric resistance baseboard. It has served us very well. And this was the first heating source that I installed to the house. It was the only source of heat that we had for the first year. It was only after the first year that I installed the mini split. I sometimes refer to this as the poor man's radiant floor because that's how we're heating the living space upstairs. Now, a lot of people have questioned, hey, isn't this a waste of energy heating the crawl space, considering that we're not living down here? And I would say no, because the thermal envelope is on the foundation wall and on the dirt level. There's no insulation in the floor joists above us. So that's the only direction the heat can flow easily and readily. Yes, there's going to be some loss to the ground, some loss through the foundation wall, but it's very minimal considering that I have super insulated this envelope. Alright, thanks. I'd like to wrap up this video by mentioning design load. The design load of this house about matches this. Now, this is my wife's hair dryer. It's 1800 watt or approximately 6100 BTUs. I can't run that continuously, but what I have done is tried running this guy continuously, and this is a 1400 watt or about 4700 BTU space heater. Now that will work when the outside temperature gets down to about 10 degrees, but after that, any colder, it doesn't hold up. But that's about the design load. This is a very energy efficient home. It doesn't take a lot. My favorite source of heat is that electric baseboard downstairs. But primarily, when the opportunity is there, we'll use the mini split. If you like these videos, please subscribe and share them. If you have any questions, leave them in the comments below.